And welcome back to Mr. Gregorius Math. Today we're talking about solving linear inequalities. And so what that's going to require us to do, it's going to require us to graph lines to evaluate whether or not a test point is above or below a line, and therefore in that actual inequality solution, and then to look for the overlapping of two solutions. So in example 4, you can see I'm asked to solve a system here that's on the board, and I have two lines in slope line intercept form. We're going to graph line number 1 in this brown color. So we'll go over and we'll start at the y-intercept of -2. We'll make a mark. Then we'll use our slope of -3/4 to get to our next point. So from here we'll go down 3 as that's our rise, and then over 4. And that looks to me to be that next point. So we now have 2 points on our linear system, linear equation, and all we have to do is connect the dots. Now, I need to make sure that I draw my boundary with an appropriate line. If it's a greater than or less than sign, I'm going to want to draw it with a dotted line. If it's a greater than or less than an equal sign, I'm going to want to draw it with a solid line. Kind of like hard-boiled and soft-boiled. So, this is just greater than, so we're going to draw it with a dotted line. I almost made a mistake drawing a dotted line through this portion here. Make that a little bit more clear. Sorry. Okay, now that we have our dotted line, we have to actually check to see which side of the line is the solution to the first equation. So 0, 0 is a nice point to check with. What we ask ourselves is, if I replaced y with 0 and x with 0, would this statement be true? Well, let's go ahead and do that. If I replace these with 0 and 0, 0 is greater than, well, this term goes to 0 anyways, because anything times 0 is itself. So is 0 greater than -2? And I believe the answer is true. So yes, 0, 0 is in the solution of the brown line, and we can shade this entire region above the line, as it's where all of our valid solutions exist. All right, now we'll go ahead and graph our second line. We'll do that in this nice emerald green. So I'm going to start at the y-intercept, and we have +3, so I'll go up 1, 2, 3. It's like a quarter dozen right there. And then I'll use my slope. I've got a rise of 2 and a run of 5. So I'll go up 2 more, 1, 2, and over 5. And that looks to be right about there. And so I've got 2 points on my line, and because it's a less than or equal to, I'm going to draw this one with a solid line. So not a dotted line, but a solid line. And if we were just graphing linear systems, the solution to that linear system would be the point of intersection. But because we're graphing a system of linear inequalities, we're actually looking for where the regions overlap. So we have to decide which side of this line to shade as well. So we'll go back and do our old trick. I'm going to use 0, 0 as a test point. So is 0 less than or equal to 2/5 times 0 plus 3? Well, 2/5 times 0 is 0. So is 0 less than or equal to 3? And I believe that that statement is true. So I'm going to shade towards 0 for my green line. And that's everywhere in here. And what I should be able to see is that I have one region that's been shaded in twice. So I'll highlight it in yellow. Oh, better grab my ruler. So that region that's shaded twice is bound by this solid line from equation 2, and it's bound from this dotted line from equation 1, and it's anything contained between the two of them. So I can kind of get rid of the rest of my shading and really firm up. Where'd my yellow chalk go? Sorry, it's tough to see in this. I don't have any yellow. It's no yolk. And so this entire region of our graph is the solution. And that's it for today. So join us next time, and we'll be taking a look at solving linear programming tasks with intersections of solutions, a little bit of algebra, and some solving linear inequalities. Don't forget to hit like, subscribe, and the notify button as it helps us with the algorithm. Take care.